Hello students. This is the second lecture of chapter solution. So here are some questions which consider to be as the worksheet, in which you will get the answer on first page of NCRT. On first page. On first page of NCERT. Okay, so you read this page and afterwards you are able to give the answer of this question. So the questions are: what are the alloys? I think you might be knowing the about the alloys, and write the composition of. You have to talk about the composition. What contain in brass, what contain in bronze, and here is a new one that is called the German silver, because this thing have already asked in the previous board exams, so you must know about the composition of all, because every point in NCRT will be important. Okay, so the next question is: how much amount of fluoride ion is used in the prevention of tooth decay? It is used in the toothpaste, so you have to tell about the amount of the fluoride ion. How much amount? It is also given in the first page, so you will read it and you will get to know about the answer. And third question is: what will happen if the concentration of the fluoride ion increase to 1.5 ppm? Then what is happening? You have to talk about the concentration of the toothpaste, and afterwards what is happening when the concentration is increased to 1.5 ppm. Okay, so you have to talk about the concentration. Okay, so then fourth one is: which substance is used in the rat kill poison? Write the concentration of it. Okay, the same thing, concentration. You have to talk about the concentration, as in solution we have already discussed the concentration plays an important role. So these all questions are based upon the concentration and composition. Okay, so in my first question you have to talk about the composition. Okay, thank you. Hello students. So this is our third terms of type first concentration term, as we have already discussed about the two terms of type 1 concentration term, that is called the first one was percentage volume by volume, and the second one is percentage weight by volume, and this one is the third, and it is very important, very important, that is called the molarity. So first of all, we will discuss about the molarity, its definition, its formula and notation, and afterwards we will try to discuss its physical aspects, as well as we will also discuss some numericals based upon the molarity, though it is very important, so understand it carefully. So now let's discuss about the molarity. So what molarity is? So the definition is very simple: the number of moles of solute. Mind it, moles comes first time. This is the first concentration term in which we are using moles. Okay, I think you might be aware of moles. Okay, we have already discussed about moles in 9th class. So number of moles of solute dissolve in per liter of solution. Per liter, we are talking about per liter, it means we have to take volume over here. Okay, so we will take volume. Which volume? Solutions volume. Okay, so it is denoted by capital M. Mind it, it is denoted by capital M. Okay, it is denoted by capital M. The formula of molarity will be the number of moles of solute, as we have already discussed, the number of moles of solute dissolve in per liter of solution. So solution in liter. Okay, so that is called the molarity. So the formula will be M, number of moles of solute, it is denoted by N, solute, and volume in liter. Afterwards we have we also know the formula of number of moles as the number of moles equal to number of moles equal to given mass divided by molecular mass. So we have the other version of the molarity, that is the weight of the solute, the given mass, and the molecular mass of the solute, that is the molecular mass m solute multiplied by volume in ml. See, in laboratory when we are doing the experiment, so it is quite difficult to take the solution in liter, so usually we take in ml. So here in the formula we are using in liter, so we convert it into the liters by multiply it 1000. So volume in ml, because in laboratory we are using the small quantity of volume, so multiply it by 1000. So this is general introduction about the molarity. There are lots more stuff which we are going to discuss about the molarity. Okay. So students, this is the continuation of the molarity, in which we have, as we have already discussed about the formula of the molarity, it is capital M, as we have discussed that molarity is denoted by capital M. So this is molarity. The formula is number of moles of solute dissolving per liter of solution. So this is the formula, and this is the abbreviation. Number of moles is converted into the given mass divided by molecular mass. Okay, given mass divided by molecular mass. So this is the number of moles multiplied by volume in ml. If volume is in ml, then we will multiply it by 1000 to make it in liters. So here is the physical aspect of molarity. Here is the physical aspect of molarity. So this is the general abbreviation of the solution. Solution is made up of solute plus solvent will give rise to solution. From the formula, it is fixed that the volume of the solution will be always 1000 ml, or we can say it is 1 liter. 1000 ml means we are talking about 1 liter. It means our solution cannot go beyond 1 liter. I am repeating it. It means our solution cannot go beyond 1 liter. Its value is fixed. Okay, so that is 1000 ml, or we can say 1 liter. As we have already discussed, solute we will use in the moles. So the number of moles, here is the number of moles of solute which is adding in the solution. The value of the solution will be fixed, that is 1 liter. So this is solution, the value of the solution will be fixed, that is 1 liter. So this is basically the physical aspect or experimental aspect of molarity. ठीक है, take it carefully, इसको अच्छे से समझना है. This is the value of the solution which is fixed, that is 1 liter, and the number of moles of solute dissolved in the solution. Solution cannot go beyond the 1 liter. Solution will be fixed, that is 1 liter. Done. So here we are discussing a numerical problem which is based upon the molarity, because molarity is very important topic which contains lots of numericals. Okay, not in board exam as well as in competition exam. So it is mandatory to make the notes plus the practice of the numerical as well. Fine. So what is the question? If 30 gram of urea dissolved in sufficient water to prepare 2 liter of the solution, then determine the molarity and percentage weight by volume. Okay, so I think we have sufficient data to solve this. First of all, the main thing is this: whatever the data is given to you, write it up. First of all, write it up. Okay, so we know that the solute is, what is the solute? Solute is urea, that is urea. The formula of urea is NH2CO NH2. Okay, so molecular mass of the solute will be, from here we can calculate it is 60 gram. Okay, it is 60 gram of the urea, and the given mass of the solute, it is given 30 gram. So write it there, 30 gram. Volume is also given, the volume of the solution, that is volume of the solution, it is already given in the liters, so no need to change it. So according to the definition, here we are discussing the first problem. We have to calculate the molarity. What is the formula of molarity? Write it again and again so that it will be on the tips of yours. So molarity, the formula of molarity will be number of moles of solute divided by volume in liter, and the number of moles of solute given mass divided by molecular mass. The given mass is the 30 and the molecular mass is 60, so that will be 30 divided by 60 into 2, because the volume is already given in the liters, so that will be 1, 2, that is 1 by 4, or we can say 0.25, as it is denoted by capital M. Moles per liter, the unit will be moles per liter, or the 0.25, 0.25, so that will be the molarity. Now the second portion is, it is from our previous concentration term, that is the, we have to calculate the percentage weight by volume. Very simple, no need to calculate the moles, because moles are used in the molarity. Here we can use the directly the value of the solute, that is 30, given mass, volume is 2 liter, that is 2000 कर देंगे, because it is in the liter. Okay, multiply by 100, because it is in the gram and it is in the liter, so converted into the ml, both will become same. So cut it down, काट दो इसको, that will be 3 by 2%, so it is 1.5%. Fine, so that is the problem. So I am giving one problem to you, so solve it at your home. इसको जरूर try करना घर पे. So that is the, I am writing it up, then solve it. The question is, second question I am writing, what is the molarity, what is the molarity of 20% NaOH aqueous solution? Okay, I'm repeating it. What is the molarity of 20% NaOH, sodium hydroxide aqueous solution? Fine, try it. Solve नहीं हुआ, then we will discuss it. Fine. So here we are sum up about the molarity. Whatever we have studied about the molarity, let's sum it up. Molarity, the number of moles of solute dissolving per liter of the solution, a solution in liters. Okay, so abbreviation will be number of moles of solute, it is N solute, the volume of solution in liters. Fine, so number of moles of solute, we can also convert it into the given mass divided by molecular mass. Let given mass will be W of the solute, given mass, molecular mass of the solute will be M solute. So put it in place of N solute, that is given mass of the solute divided by molecular mass of the solute, multiply by the volume in ml. So we can convert it into the liters by multiplying it 1000. So this is the exact formula of the molarity. Okay, one more important part which is also come out of here, that is the if we have to calculate the number of moles. Okay, because this particular relationship we will use in the further numerical problem. So now take it carefully. This is what? This is molarity. This is molarity. It is equal to the number of moles of solute divided by volume in liters. Fine. If we have to calculate the number of moles of solute, then it will be equal to, so number of moles of solute basically equal to molarity multiplied by the volume. So this particular abbreviation we will use like this. So N of solute will be equal to M into V, molarity into volume. So here is the another formula for calculation of the number of moles. Fine. So this is all about the molarity. Thank you. So students, this is the fourth concentration term of type 1 concentration, that is called normality. That is called normality. In this chapter, the importance of normality is very less, because there are very few numerical based upon the normality. But we should know about it, so we will discuss it. Let's take the definition. Number of gram equivalents. Basically, in this particular concentration term, you will get to know so many new terms. So careful about the definition and the new terms. So here is the new terms which come in front of you. That is called the gram equivalent. That is called gram equivalent. So we will discuss it about the gram equivalent. So number of gram equivalents of solute. We have to calculate the gram equivalents of solute. Remind it. Okay. Dissolve in, at last so we will get the per liter of the solution, as we have already discussed in type 1 concentration. In the denominator you will always find the volume. Okay, so volume of the solution again. But now the new term is number of gram equivalent of solute. Let's calculate it. We will calculate it, and now first of all we will discuss the formula. It is denoted by capital M, as in molarity we discussed it. It was denoted by capital M. It is denoted by capital N. Normality N. Okay. So normality will be equal to number of gram equivalent, again the same term, divided by the volume of the solution in liters. Again we will convert it into the ml and multiply it by the 1000. So that is the later on process, but now, as of now, this is the formula. Now how we can calculate the number of gram equivalent? So there is a formula called number of gram equivalent will be equal to given mass of the solute. Again we have already discussed the given mass as W of the solute, that is given mass of the solute, and here is the again new term, that is called the equivalent mass of the solute. See, we are trying to find about the number of gram equivalent and stuck into a new term, that is called the equivalent mass of the solute. So first of all we should know about the equivalent mass. After getting to know about the equivalent mass, we can have the number of gram equivalent. So the next part will be equivalent mass of the solute. Okay, so there are so many methods to calculate the equivalent mass based upon the compounds. So for the calculation of equivalent mass we should know a chart. So first of all we will draw the chart and then discuss the equivalent mass. So before the calculation of equivalent mass, understand it why we need equivalent mass actually. Okay, so I am writing again the formula of normality and about the all parameters which we have to solve, which is used in the normality. So at least we should know about the equivalent mass, why we have to calculate it. Okay, we should means know about the equivalent mass, why, what is the need of it. Okay, so normality is number of gram equivalent of the solute per liter of the solution. The number of gram equivalent, the formula is given mass of the solute, that is W of the solute divided by equivalent mass. So that's why we need it, because we have to calculate the number of gram equivalent, and number of gram equivalent is used in the formula of the normality. So first of all, for the calculation of the number of gram equivalent, we should know about the equivalent mass. So here is the for the calculation of the number of gram equivalent, we should know about the equivalent mass. So the question arises, how we can calculate the equivalent mass. So the further proceeding about the equivalent mass. So students, here is the calculation of the atomic mass. Even no need to worry, the chart is seems to be very pathetic, but you know the calculation is very easy calculation. One thing we should know about the calculation of the atomic mass, we should know about the compounds, that for what compound we are going to calculate the equivalent mass. Okay, like for element it has something different formula, for acid it has something different formula, for base it has some different formula, for salt it has some different formula, even for iron it has some different formula. But there is a means common factor is working in all the formulas. So let's take one by one example of the each compound, in which we get to know how to calculate the equivalent mass. So first of all, the calculation of the equivalent mass of an element. Say if we see the numerator part, in every numerator part you will see there is a molecular mass. So what we have to add in the numerator, that is the molecular or atomic mass. If we are talking about element, so then we will consider the atomic mass. If it is a compound, then we will consider the molecular mass. So simple as, if we are talking about element, then the atomic mass of the element. Say we are talking about sodium. Okay, so we are talking about the sodium. The formula is, the symbol is Na. So atomic mass of the sodium is 23. Valency of the element, we know that the valency of sodium is 1. So the molecular mass and equivalent mass is same. Say further take the case of calcium. Okay, so calcium, the molecular mass is atomic mass of calcium will be 40 and the charge on it is 2. So the equivalent mass for calcium will be 20. Understand? The equivalent mass for the calcium will be 20. Same, one more example I am taking about the nitrogen. The molecular mass is 14 and the valency is 3. So this is the, that is the 4.6. The equivalent mass will be around 4.6. So this is the calculation for the equivalent mass for element. Understand? So just atomic mass divided by the valency. If the valency is 1, then the atomic mass and the equivalent mass will be same. Fine? Easy? Okay. Now take other example. Take other part, like of acid. Something we should know about the acid, the same will be apply on the base. The same. Here the formula is molecular mass of acid. is quite easy. We can easily calculate the molecular mass of acid. Then the term is used as basicity. It is the divide of the molecular mass by the basicity. So what is basicity actually? We are talking about acid, and here we are talking about the basicity. It means basicity of an acid is the number of OH ion neutralized by an acid. Okay, कि कितने OH ion न्यूट्रलाइज कर देगा ये वाला एसिड is called the basicity of this acid. For example, in simple way we can say the number of H positive ion released by the acid is called the basicity, because that H positive ion will neutralize the OH negative ion now. So that's why this is nothing but this is the basicity of the acid. No need to confuse. Basicity means you can easily calculate the number of H positive ions released by an acid, but this is not the definition actually. Definition, in the definition part we use the term neutralization of the base ion. Okay, so understand it carefully. Just say we have good example of this is like, say, take the example of HCl. Molecular mass of HCl will be 36.5, and how much H positive ion released by HCl? Single H is there, so 1, so basicity will be 1. So this is the equivalent mass of acid. Again, take the case of H2SO4. In H2SO4, how much H positive ion released by the H2SO4? That is 2, because 2 are there. So 98 divided by 2, that will be 49. The equivalent mass for H2SO4 will be 49. So think it carefully and do it carefully. Okay. So next, again the same thing is there, that is of base. If we are talking about basicity for an acid, then for base we are talking about the acidity. The definition is still reverse. इसको reverse कर दीजिए. If we are talking about the base, that NaOH, how much OH ion is released by this? That is 1. So the answer will be 40 divided by 1. Like this is a question for you in the calcium hydroxide. How much OH ion is released by this calcium hydroxide is 2. So take the molecular mass of calcium hydroxide divided by 2. You will get the equivalent mass of it. Fine. Understand this? This is very important. So the next is salt. We know that how salt is produced by removing one hydrogen atom or hydrogen atom by replacing hydrogen atom with the metal. Say this is HCl, replace it with the help of sodium. The formula will be NaCl. So this is salt. Okay, because it is produced by replacing hydrogen atom with any metal. So the question arises, only sodium can replace? No, you can replace it by calcium, so it will become CaCl2. This is also salt. Fine. The salt are so many. Then how we can calculate the equivalent mass? The same way, in the numerator, so we have only the molecular mass of the salt and divided by the positive valency. We know that the hydrogen is replaced by any metal, and metal have only electropositive. They have the positive valency on it. So whatever the valency is there, divided by this. So we know that here the positive valency is for sodium, that is 1. So it will be 58.5 divided by 1. For calcium it is 2, so divided by 2 कर दो. That's all. Fine. The same way में iron, whatever the iron we are having, so calcium plus 2, same 40 divided by 2 if we are talking about iron. So whatever the formula mass we are using for the ion, because uh, we are taking the 1 mole of the substance, so it is formula unit, and the formula unit से मिलकर बना है formula mass. So whatever the charge on it, that is divided by the denominator. Whatever we are talking, say chlorine -1, so it will be 35.5 divided by 1. So, okay, so that's all about the equivalent mass. Do it carefully, understand it, and now we are able to calculate the normality on the basis of equivalent mass.